In this lesson, we'll take a look at the concept of scope, which describes the boundary or the context in which a variable is allowed to be used in our VBA program. There's actually three types of scope available: macro scope, module scope, and application scope. And again, these just define the boundaries in which a variable is available to be accessed by us. Let's take a look at the simplest example, and that should help clear things up for us. So I'll begin by declaring two procedures here. The first one I'll call procedure A, and the second one I'll call procedure B. And in my top level procedure, I'll declare a variable. I'm going to call it mynum. I'll make it a whole number, and I'm going to assign it an arbitrary value, let's say 10, and then just debug print it out to my console or my immediate window. And right here below in procedure B, I'm going to do something interesting. I'm going to try to debug print the value of mynum again. So let's go ahead and try this. I'm first going to click into procedure A and execute this. Let me see what's going on here. This is actually debug print. When I click into here and press F5, we're going to get the value of 10. Everything looks great. And you might think that when I execute my code right here, procedure B, you might think we're going to get the exact same result in the immediate window. But instead, we're going to be greeted by a compile error. We can see here variable is not defined. So when I click OK here, I'm going to be launched into this debugging mode, which we can immediately tell we're in by this presence of this yellow line. We can exit that mode by simply clicking the blue reset button. And we can see here that VBA is struggling with this mynum right here. So how come it's running into this issue even though we declared mynum up here? Well, that's exactly the answer. We declared mynum in a totally separate procedure, and variables that are defined or declared in the body of a procedure are scoped to that procedure. What that means is they don't extend outside the boundaries of that procedure. What's actually happening here is whenever we run procedure A, after all this code is processed, VBA is going to take the mynum variable and completely throw it out of memory. It's not going to exist. So by the time we get here, VBA has no clue what mynum is. That variable is scoped to or limited to or bound to the confines of the procedure in which it is invoked. That can actually be advantageous for us because we can do a brand new variable declaration in procedure B and use mynum again. So we can, for example, copy this code. And let's say right here, we can make mynum equal to something like 50. And now when I execute these two in sequence, we're not going to run into any kind of problems even though we declared the same variable twice, because each variable exists within its own boundary, within its own procedure. So when I execute this with F5, we're going to get 10, and when I execute this here, we're going to get 50. In fact, because each variable is bound to its own procedure, we don't even have to give it the same data type. It completely exists in its own separate world. So if for some strange reason I wanted mynum to be a Boolean here, I could totally do that. I can make mynum a Boolean, I could assign it to true, I can execute this right here, F5, and you can see right here, we're going to get a value of true. And VBA is not going to run into any kind of error. It doesn't care that's a long in one and a Boolean in another, because both of them exist kind of in their own sandbox, in their own playground, in their own kind of bound place where they can be used. That's what we mean by scope. It's the boundaries or the context in which a variable is allowed to be used. And this one, of course, is called the procedure scope or macro scope because it's limited to the macro or the procedure in which it is actually defined. There's actually two more available for us, so let's take a look at the second one now, which is module scope. As the name suggests, a variable that has module scope is actually going to be available to all procedures within the current module. So right now our workbook only has one module right here, module 1, so we can declare a variable that all of our procedures can use. For example, up top here, what I can do is actually declare a variable outside of any procedure. I'm going to do it right in the module body. So for example, if I want to do mynum right here, mynum as long, what that's going to do is declare a variable mynum that is going to be available to be used by any procedure here, and it's going to retain its value even after that procedure is done executing. The one big caveat here is that we can't define or give mynum an initial value outside of a procedure. So all we can do is declare it and give it a data type, but we can't actually do something like mynum equals right here. We can only do it in the body of a procedure. But let's take a look at how we can do that. Right here in procedure A, I no longer need this code. So what I can do is get rid of this. Let's say we assign mynum equal to 10 and then debug print it. And what I want to do here is change this. Let's debug print mynum again. And let's change mynum now to another number. We have to now follow that constraint because this is the one that's ultimately going to take precedence. So it has to be a whole number. So let's change it to something like 25. Let's get rid of my output below. I'll first begin by executing procedure A. And this result should be pretty predictable. So we're going to get a value of 10. That's not a problem. So what happened here is we now have a variable called mynum. It's available on the module level. We're finally assigning it a value in procedure A, and then we're outputting it that value. Now, as soon as procedure A is done executing, mynum is still in memory. Unlike variables that are defined in the actual body of a procedure, module level scope means that the variable will be preserved. So mynum is still in memory, and it's still equal to a value of 10. We can prove that by executing procedure B. Right at this point, mynum is still going to be equal to 10, so we're going to see that number, then we're going to reassign it to 25, and then see the new value. So when I execute F5, we can see this second 10 is coming from procedure B because mynum has already been assigned that value. So what module scope allows us to do is declare a variable that is used across multiple procedures. This is especially helpful when multiple procedures are going to be modifying some kind of variable if you need them both to be targeting the exact same object or the same kind of program entity. You can declare that variable outside of a procedure to make it module level. In fact, a really good application of this may be something like a Excel VBA object. For example, you may have procedures that are acting upon the exact same range, and you may simply want to declare a variable that's going to represent that range in all of the procedures, maybe dim RNG as range, and that way you can continue to define and assign RNG throughout multiple procedures and have that single variable declaration at the top. It reduces a little bit of your duplication. The third and final variable scope available to us is application scope or global scope, and this is taking it one step further. Any variable that is declared with this scope is accessible not just in any procedure in this module, but in any procedure throughout any module within our workbook. So what I can do here is show you first the syntax, but what I also need to do before I get there is create a brand new module just to show you this in practice. So I can insert a brand new module right here. Let's go back to module 1. And there's a little bit of a syntactical twist that we have to do to make this work. Right here, when we're declaring mynum, instead of using the dim keyword, we have to replace it with a brand new keyword, which is public. Public mynum as long. So the syntax is very similar to the variable declaration. We're still going to give the variable a name, mynum, and a data type of long, but instead of dim for dimension, we're making it public, so we're writing the keyword public. So what this means is mynum will still be available right here. We can prove this, in fact, by executing these two procedures in sequence, and everything is still going to work just fine. So it has all the benefits of module level scope, but now mynum is also going to be available in any other procedure, in any other module, actually. So if I go into module 2 and I write a new procedure like, let's say procedure C, and let's keep things simple right now, let's just debug print mynum, this is totally going to work. So when I execute this with F5, we're going to get 25 output right here. Again, let me in fact delete this and re-execute to show you. And the reason this is happening is because mynum is number 1 still in memory, and number 2 available globally across all modules because we put that public keyword prefix right there. So mynum now, even though there's no evidence in module 2 that it's available, this declaration of public in module 1 makes it available through any single module that we're going to be adding to this VBA project. Now, generally speaking, when should you use this? Generally, application level scope, as this is called, or global level scope, things being available globally everywhere, is generally discouraged because it kind of makes your code potentially a little bit clumsy and messy, where you might have to look into a different module to find out where something is declared, to find its data type. Ideally, each module should strive to be self-contained and kind of independent and autonomous on its own. So you may need something like a module level variable at the top, but you can still scroll down and see the procedures that use it. Whenever you have to start jumping around different modules, it makes things a little bit complicated. But if there's ever a scenario where you do want to make something global, just know that that is a possibility, and you could make it so with the public keyword. If you just want to make something available at the module level, you replace public with dim. And if you want something to be available simply at the procedure level, all you have to do with those variables is just declare them inside the body of a procedure right below the sub keyword, and they will only exist as long as that procedure is done running. In comparison, public level or application level variables, as well as module level variables, will continue to persist even after one procedure is done running. So they hold on a little bit longer. You may find that when you're writing your code, that's the kind of design that you may need depending on the program that you're building. But that's all there is to cover in this lesson. We talked about the 3 types of scope: module level, procedure level, and application level. Play around with this, practice the public keyword, and I'll see you in the next lesson. In this lesson, we'll take a look at how we can call or execute a procedure from the body of another procedure. So far, all of the examples in this course of procedures have been pretty simple. They've been limited to a small number of lines. But whenever we're working with real-life business logic, it's highly likely that we're actually going to be dealing with a lot of different objects, worksheets and workbooks, and code is going to expand very quickly. Many times, instead of having a huge block of code in a single procedure, what we can do is split up that code into several smaller procedures and then kind of have each procedure have its own distinct and unique purpose. This is part of the larger scheme of what we call refactoring in programming terms. To refactor something means to make something simpler and more efficient. So past the point of making code simply work, past the point of making it actually do what it's supposed to do, we can also write code in a way that is more elegant and more efficient, and breaking up our longer procedures into smaller ones is one way we can do that. So in this lesson, let's take a look at a very simple example. What I'm going to do is define a procedure. Let's call it master. And let's say right here I have a whole bunch of business logic and it's taking up a whole bunch of space. And let's say for now, just to kind of mock a real life scenario, let's say it's just a matter of having two debug print statements. Like maybe I have debug print, hey, this is the first step. And let's do another debug print here. Hey, this is the second step. And imagine that instead of having two debug statements, we really have maybe 40 lines of code for every one of these debug prints. And what we want to do is move each one of these operations into its own separate procedure. Well, here's what we can do. We can declare those procedures. Let's say up top, I'll declare a procedure called step 1. And I'll move my debug print logic into there. And again, imagine this is 40 lines, not one. So let's put that here. And then right below here, we can have something like step 2. And usually, instead of simply calling it step 1 or step 2, you might have a procedure that is descriptive of what it is that's actually happening. So if you have a master procedure, it might call two procedures in a row that are going to describe exactly what's going on in the process. Maybe step 1 will be do something with the workbooks. Maybe step 2 will be do something with the worksheets. So right here, let's go ahead and copy this debug print code right here. Again, imagine this is 40 lines instead of 1. And now all we need to do here in master is actually get these two procedures to run in sequence. And it's a pretty simple operation. All we need to do here is use the call keyword. This is a brand new keyword that we're seeing in VBA. And we follow call with the actual name of the procedure that we want to invoke or execute. So in this case, I want to begin with step 1. So I simply write step 1. On the next line, in order to execute step 2 right after, or the second procedure, I can just write call step 2. Now, obviously, the order in which we write this is going to affect the order in which they're executed. So this one is going to take place first, followed by step 2. All right, and it's not going to proceed to executing step 2 until this entire procedure is done running. So let's take a look at this in our immediate window. When I execute this, we're going to see the procedures execute. So master right now is just kind of the container that's kind of the business flow of logic, and it's relying on two other procedures to do what it needs to do. It's a pretty simple example, but hopefully you can sort of use this to imagine how you might use this in a real life scenario that's involves a lot more of complex code that takes up a lot more lines. You can split it up into as many procedures as you want. It's really up to you to decide what is comfortable for you, what feels compact to you. Ideally, each procedure should do one thing. If you ask yourself, what is this procedure doing? And you find yourself using the word and a lot, it does this and with workbooks, and it does this with worksheets, and it does this with the font, it's probably doing too much, and you could split up that procedure into multiple ones. Once you write those secondary procedures, all you have to do is invoke them or call them. We do that in our master procedure with the call keyword followed by the name of the actual procedure that we want to utilize. It's just another way that we can refactor or simplify our code. In this lesson, we'll talk about how we can set up procedures that accept arguments. Now, we've seen arguments before when it comes to some of VBA's built-in methods. Well, we can actually define procedures that are going to accept their own inputs as well. Let me begin here by defining a new procedure. I'm going to call it write calculation to sheet. What I want to do here is just declare a numeric variable. I'm going to call it math calculation. It's going to be a long or a whole number. And let's say I'm just going to create an arbitrary multiplication expression here. Let's do 5 times 4 times 3 times 2 times 1. Let's say I want to do 3 things here. The first thing I want to do is to log this message to the immediate window or the console with debug print. The second thing I want to do is to output it with our message box. And the third thing I want to do is to actually write it to the sheet in cell A1. Now, this is a very simplified example because all of these things are pretty simple one-line bits of code. But you can imagine if our macro starts to get really, really long, for example, 50 lines, 30 lines, we may want to split it into multiple procedures. That way, we can encapsulate related clumps of code together in a separate procedure and then simply invoke that procedure from our main procedure, as we saw in the last lesson. So let's say I want to do three things here again: log, output, and write. Let's define a procedure to do each one of those things, and then I'm going to actually invoke that procedure from within write calculation to sheet. So right here, I can define a procedure called log message to console. I'm going to open my parentheses. Here's my end sub. And here we run into our very first question, which is, how is log message to console going to have access to the thing that it needs to actually output to the immediate window? We know that we have debug print. Debug print accepts a value, but where is that value going to be coming from? We know that our variables within a procedure are scoped within that actual procedure. So the math calculation here, let me actually change this typo, math calculation here is only available within write calculation to sheet. So how can we give it to log message to console? Well, we can actually pass it in as an input or as an argument. So let me just write out the procedure invocation first. Log message to console. We know that we're going to have to give that procedure its argument, which is going to be math calculation. So how can we actually tell log message to console to expect a single parameter or argument? Well, all we have to do is just define it within the parentheses. Now, the name of the parameter that we give here, of course, does not have to match the variable that's being passed in. This variable is, remember, just a name for some kind of mathematical value. It's just a number. Here we're actually defining the name of the parameter or the name of the input that we're expecting. So I can just call that something like value. This can be anything: value, number, even input. The only other thing we need to do here, though, is to tell VBA not just the name of the parameter, but what kind of data type VBA should expect. The way I do that is the same way I declare variables. I use the as keyword, a space, and then I declare the data type. So our value is going to be what kind of value? It's going to be a long. So now we've told log message to console that it's going to expect a single input or parameter. We're going to call that value. Math calculation is going to be the argument for that input. It's going to be a long or a whole number. And now that we have it, we can go ahead and output it to the immediate window with debug print and value. Let's go through this process a few more times. Right below here, I want to define a procedure that's going to message box the value out to the user. So what I can do is just write a procedure like output message to user. And right here, again, we have to define the input and or the parameters, it's also called. And because, remember, all of the procedures are separate entities and they're all scoped differently, including the parameters, not just the local variables, we can actually give the input or parameter the same name as we did to the procedure above. We can call it value. It doesn't have to be value in either case, but why not keep it the same? Keeps things simplified here. So value is once again going to be a long. Once I close this, VBA is going to complete my end sub. In this case, I'm going to just message box the value. Now again, this procedure doesn't actually do anything until it's invoked, until we actually use it. So here in write calculation to sheet, what I can do is actually write output message to user. That's what I actually want to use. Open my parentheses, pass in the same argument of math calculation. Close this. It looks like VBA is actually adding an additional space here. Totally fine. It's just correcting our syntax. This should all be valid. And let's do one more example. In fact, if you want to practice this yourself, you're more than welcome to pause the video and try. What we want to do in our third and final procedure is take in the value and simply write it to cell A1. How can we do that? Well, we define a procedure, write value to sheet. It's going to take an input. Let's call our input value once again. Is it going to be a different data type? Nope, it's still going to be a long. All right, what do we want to do here? Let's target range A1. Let's write in the value, and I'm just going to do range A1 value equals value. Totally valid syntax, remember, because this value represents the argument that's being passed in. This is just evaluating to a number, while this value is a property on the range object. Last thing we need to do, of course, is to actually write the invocation right here, write value to sheet. I'm going to do the right syntax here and actually offer a space here. Once again, we're going to pass in math calculation, and that's it. So hopefully you're also starting to get a sense of how refactoring into multiple procedures can help you make code that's a little bit leaner. You can see that because we've refactored all these operations to separate procedures, this one isn't that long anymore. Granted, all of these things are still one line, so it would have been the same number of lines, but you can imagine if this represented some kind of step of sequences that was something like 5 lines or 10 lines, we can make our code a little bit more concise by refactoring things into separate procedures. That way it's just more lightweight for each procedure. Each one's kind of its own self-contained box of functionality, and we don't have one super long procedure that becomes hard to interpret. Let's go ahead and see what happens here. Obviously, these are going to be executed in sequential order, so they should happen in the order in which they're written. So I'm going to press F5. First thing that's going to happen, we have our debug print. It happens right here. Remember, that happens instantaneously to the immediate window. Then it moves on to the message box. That's why this thing pops up. The message box actually puts a pause on everything. That's why we're not seeing the value here in cell A1 yet. Once I click OK, there it is. And that's all there is to cover in this lesson. We talked about creating procedures that accept arguments. By the way, of course, this might seem obvious, but you're not limited to longs. You can put whatever data type you want in here. You can put strings or booleans. You're also, of course, not limited to single inputs or single arguments. You can, of course, just define multiple ones. All you have to do here is just simply put a comma and declare the next parameter. Again, just give it the name, the as keyword, and the data type, and then you could use 2 parameters, 3 parameters, as many as you want in a procedure. That's all there is to cover here. I'll see you in the next lesson. A few lessons ago, we talked about variable scope, which defines the boundaries or the context in which a variable exists. In this lesson, we're going to talk about procedure scope, which defines where a procedure can actually be called from. Let me begin by giving you a few examples. So far, all of the procedures that we've written throughout the course have been public. This means that they are easily available. They're available both within the Excel interface. We can access them from the macro dialog box. They can be invoked with something like a keyboard shortcut, and they're also available for other procedures within our module to use for their own sake. So for example, if I declare a procedure here, I'm going to call it implicitly public, and I'll explain why in just a second. Let's say I make this procedure do something very simple, like message boxing out the value of 1 plus 1. By default, all procedures are public, which means they are going to be available in the Excel interface. So if I go to my macros dialog box right here, we can see implicitly public written out here. The reason it is implicit is because the public nature of it is assumed, because that's the default nature of VBA. What I can actually do is explicitly declare a procedure as public. So I can actually use a keyword here called public right before a basic procedure definition. So I can create a new procedure called explicitly public. Let's make it do the exact same thing, just message box 1 plus 1. And let me just explain what we did here. These two procedures are identical, not just in what they do, but in their procedure scope as well. So this keyword is not needed here because it's going to be assumed. So both of these procedures are going to be public. Both of them are going to be available in our drop-down list. The user can activate or call any one of them, either one of them. They're both public. The reason why some developers prefer to add this extra word in here is because it makes it a little bit more clear once we start writing private procedures as well. It makes it more clear which ones are public and which ones are private. There's kind of a consistent naming scheme where if we're going to label which procedures are going to be hidden away from the user, we might as well label those procedures that are going to be accessible by the user. So sometimes, even though this keyword is not necessary because the default behavior of VBA is to make a procedure public, some developers prefer to put this so it's a little bit more kind of written out and well documented. So now let's talk about private procedures. Private procedures are only visible to the procedures in the exact same module. They cannot and should not be called by the Excel user. They cannot be executed from the main Excel application. If you look at the macros dialog box, any private procedures will simply not show up. So why do we need private procedures? Well, they exist only to be invoked by other procedures. For example, if we want a procedure that's going to abstract away the complexity of a procedure, for example, we may want to take some code from a really long procedure and put it elsewhere so that we kind of have a box to contain it, and then we can simply call that procedure. That second procedure that's going to be holding together that clump of code doesn't need to be accessed or used by the user. It only exists to give us utility as a developer to make our own process of categorizing and organizing our code simpler. In that case, we may want to label some procedures as private if we don't want the user to be able to use them. They only exist for our own benefit. So let me give you an example here. Let's say I want to do some kind of operation here, like writing a value to a range right here. And let's say I don't want the user to actually be able to do that. So how can I do that? I can declare the procedure to be private. Instead of the public keyword, I begin with the private keyword. So I can do private sub. Let's call this one explicitly private because we're explicitly writing the private keyword and preventing it from being accessed by the user. The syntax, the logic, all of the basics of VBA code are going to be identical. So here we can put any kind of valid VBA code. So I'm going to do something like range a1.value. Let's just put in something like the keyword private stuff. Now the big difference is here, because we put the private keyword, this macro and only this macro is not going to be available. So we can see explicitly public shows up. That's because it has the public keyword in front of it. We see that implicitly public shows up. That's because the default scope of a procedure is public. That's why the public keyword is technically not needed. However, as soon as we add the private keyword right here, this explicitly private sub will not show up. So the user has no way to access it or run it. So let's go back into our Visual Basic Editor. And now we have access to this private procedure within any of our other public procedures. So what I can do here, for example, is say I want to invoke explicitly private. So I can do that several ways. The first, of course, is simply to do explicitly private. So I can invoke this procedure, and the user is only going to have access to this public one. But whenever they execute this, the code is going to go ahead and call this one. And after that's done, that's when it's going to output message box 1 + 1 to the user. It looks like whenever we're getting some kind of error here, it looks like we might have to add an extra keyword here, which is going to be the call keyword. Call explicitly private. And that, I think, should work. Let's also remove the parentheses. Okay, so this syntax is valid. So let's go ahead and use the call keyword. That's just a way to say run a procedure or execute a procedure. Then we're going to put the name of the private procedure that we want to invoke. That's going to be this one right here. The user, again, has no way of accessing this. So let's go back to our Excel interface. Let's go to macros. Let's run our explicitly public procedure. Let's run it. All right. So here we see the first thing that's happening is the value is being written to the range. That's private stuff. Now, remember, the user has no way to execute this on their own. They have no clue that this procedure exists as a private one on the Visual Basic Editor. This part is the second part of explicitly public, which is the message box. So everything is working as expected. That's all there is to cover in this lesson. Again, whenever you want to split up a procedure into multiple procedures and you want to abstract away some of the complexity of a procedure, many times you don't want the user to be able to have access to any of those procedures that are sort of acting as helpers or procedures that just take care of one small step along the way. You don't want the user, for example, in this case, to be able to write a value to range A1. So what you can do is make some procedures in your module private, which means that the user will not have access to them. Only other procedures within the exact same module can call or invoke those procedures, and that will help you make your code, again, more lighter, more leaner, more efficient, and rather than having really, really long procedures where you're not sure what's going on, you can refactor different sections, different blocks of code into their own separate procedures, each of which does only one small thing, and that way you just have a much more optimal, easy to read code base. In this lesson, we'll take a look at the exit sub keywords. Exit sub is used to terminate a procedure before it reaches its natural conclusion. Now, usually exit sub is paired with what we call conditional logic. Conditional logic essentially means code that only runs if a certain condition is true. So exit sub is a really ideal thing to use, for example, if all of the prerequisites for our procedure to run properly are not in place. For example, we ask the user to enter some kind of value and they do not enter a value. In that case, there's no point running the rest of the procedure, so we can terminate it early. The reason I wanted to introduce these keywords now is because they are directly tied to the concept of a procedure, which is what this section is focused on, but we're going to do a review of these concepts a little bit later in the course as well and dive into the actual conditional logic part of it. For now, let me show you how exit sub works in action. So what I'm going to do here is create a procedure called exit early. It's going to be as simple as can be. I'm just going to have a couple debug print statements here, debug print 1 and debug print 2. And right below here, I'm going to do a line break and just do a couple more, debug print 3 and debug print 4. Now, of course, if I run this procedure normally with F5, we're going to get all of these 4 numbers printed. That's expected. However, as I mentioned, we can introduce 2 new keywords called exit sub. And exactly as the name would suggest, exit sub exits or quits or terminates the procedure, the sub, at this point of execution. So VBA is going to read these two lines and execute them. It's going to get to this, and none of this code will execute. So when I press F5, we're going to see 1 and 2. Notice that 3 and 4 do not appear. And that's basically all there is to cover in this lesson. 2 keywords we put in our middle of our procedure if we wanted to terminate prematurely before it reaches its natural conclusion. Again, a lot more powerful when used with conditional logic, but we'll take a look at that a little bit later in the course. I'll see you in the next lesson. In this lesson, we'll take a look at constants, which are values that cannot change while the macro is running. So far, we've been exposed to variables, and variables, as we know, can actually have their values changed throughout the process of a procedure. We haven't seen too many examples of this, but I assure you later on in the course, when we start diving into things like iteration, which means going through rows one at a time, variables will come into play a lot because we're going to be taking, for example, cell values and consistently reassigning them to a variable. Row 1 to a variable, then row 2 to a variable, then row 3 to a variable, etc. So variables, as the name suggests, can vary. They can change. Sometimes, however, in a program, you're going to need to store a number, for example, or a string or something that is constant, that is unchanging. For example, you may have a tax rate in an accounting spreadsheet, and that tax rate is going to stay constant for the entire duration of the procedure. In those cases, you can use something called a constant, and as the name suggests, a constant is simply a different type of variable, you can say, even though it can't vary, but it's a different way that we can assign a value to a given name in our program, but that value cannot change. Once we assign a value to a name, it is there for the entire duration of the macro's execution. So let's take a look at an example in my Visual Basic editor. I'm going to define a new procedure called fun with constants. And as we know by now, if we wanted to declare some kind of variable, we would simply use the dim keyword. Well, in order to declare a constant, we simply swap the dim keyword with the const keyword, C-O-N-S-T. So C-O-N-S-T. So one example of a constant that I can think of is pi in mathematics, which is 3.14159. That value is unchanging. So if we're going to have a variable called pi, there's really no reason to ever reassign anything besides an initial value to it. So I can do something like const pi, and let's say I'm going to make it a double, a floating point number. And one of the other things that's interesting about constants is whenever we declare them, we can actually make the declaration and the value assignment on the same line. We can't do that with regular variables. So instead of simply writing pi equals on the next line, I can put an equal sign right after that declaration and give it its initial value, like 3.14159. And this sort of makes sense because the reason we can assign a value is because a constant's value never changes. It just needs a basic starting point, and that's never going to change. So we can simply assign it wherever we declare the constant in the first place. Now, there are some conventions when it comes to naming constants, and it depends on what developer you talk to. Some people prefer to put all of their constant names in uppercase. Some people prefer to prefix their constants with a lowercase letter c, C for constant. So as an example, let's say I want to have a constant that represents the total number of months in a year. I can have something like const, let's say C months. And that will be, let's say, a long or a whole number, and I can assign it to 12. And as I mentioned earlier, maybe I'll have something like a tax rate that's going to be used throughout the procedure many times, and I can declare it in a constant just for easy reference. So I can do const something like C tax rate as a double, and maybe our arbitrary tax rate is, I don't know, 0.0825. And these constants now are unchangeable. So if we try to accidentally give them a brand new value, VBA is going to throw an error. For example, if I later on in the procedure say, okay, well now my tax rate is going to be something different like, I don't know, 10. And as soon as I execute this, we're going to run into an error right here when VBA is going to say compile error, assignment to constant not permitted. So it's a constant. You can't assign anything new to it. What is originally assigned must stay constant. It must stay the same. Let's go ahead and quit our debug mode by clicking the blue reset button at the top right here. And the last thing I want to show you in this lesson is the familiar protocol that we can use to make a constant available to all procedures in a module, as well as available across the entire collection of modules in a workbook. So as we talked about a little bit earlier, if we declare something outside of a procedure in a module, it will be available as a module scope. So it can be accessed by any of the actual procedures in that module. And if I do something like that here, for example, I want to have a string, and I'm going to call that string job title. The interesting thing here is that if I do this outside of a procedure, I can actually assign the initial constant value outside of the procedure. So I can do something like VBA developer. This is not possible with a basic variable, which requires us to actually assign that value in the body of a procedure. However, a constant needs something to begin with because it's unchanging, it's kind of everlasting. So we can assign that outside of any procedure. And now if I want to use this not global, but module level constant, if I have a procedure here, for example, occupation, I can actually reference it from within. So I can do something like, let's do debug print and write something like I am a, and let's concatenate job title. And even though job title is not declared within occupation, it's going to have access to it because it's available on the module level. So when I execute occupation, we're going to get I am a VBA developer. In order to make a constant available across all of the modules in your workbook, and again, a sample case for this may be something like a tax rate for an accounting application that is going to stay constant. What you can do is just simply declare that tax rate once as a globally available constant, and it's going to be available in all procedures, and you don't have to keep reassigning it over and over. The way you declare it so that's available across the entire collection of modules in a workbook is simply by prefixing this const with the keyword public. We ran into this a couple lessons ago. It's pretty similar. Public simply means publicly available everywhere. So if I now go ahead and take my occupation procedure, I'm going to cut it, and I'm going to create a brand new module here, module 2, insert module. I'm going to put it right here. Even though job title is defined in module 1, it's still going to be available here because it is publicly available. It's globally available. So when I execute this, we're going to still get I am a VBA developer. And you can imagine here, again, if we're doing some kind of worksheet calculation with a number that we need that is consistent, or some kind of string we need that's consistent, or some kind of Boolean setting that we need, we can just simply declare those as a globally available constants and have access to them in whatever module we need. That's all there's to cover in this lesson. We talked about the idea of constants. Those are declared with the const keyword, C-O-N-S-T. You can assign it an initial value, but you cannot assign it a secondary value. That's why it's a constant. Its value cannot change. It remains static and unchanging. You can simply limit a constant to the body of a procedure, that is module level. You can also, procedure level, or local scope. You can also allow it to be used by any procedure in a module. You simply have to declare it outside of a procedure, and you can, of course, make it globally available as well by prefixing it with the public keyword. In this lesson, we'll talk about predefined constants in VBA, which are also called enumerations. The idea behind an enumeration is tying together a name with a value, or associating a concept with a given number. A good real-life example that I can offer you is ordering food in a fast food restaurant. When you walk into a restaurant and you say something like, "I'd like the number 2, what does that mean? Well, it means that there's some kind of association between the value 2 and some kind of concept or entity. So for example, the number 2 in a fast food restaurant might mean the big burger combo with fries and a soda. It also works in reverse. You may walk in and say, "I'd like the big burger combo," and the waiter or waitress might be able to interpret that as the number 2. So whenever we're associating a name with some kind of value, a number with some kind of concept, we call that an enumeration. Enumerations exist in VBA to help us as developers, and the best way to demonstrate this is with an example. So, as we know, spreadsheets have this concept of orientation. In fact, here in the Excel interface, on the Page Layout tab, we have this orientation option, and we have one of two options, portrait or landscape. We briefly discussed this, I believe, in an assignment in the past where you had to record a macro to change this option. So let's think about the concept of orientation. We have a property on something called a page setup object, which we'll explore very shortly, that allows us to set the orientation of a spreadsheet. But what kind of value is the orientation? Is it a Boolean? Well, not really. Yes, we do have two options here, portrait or landscape, but it's not so much true or false or on or off. It's more just a set of predefined options. It's either portrait or landscape. It's not really a true or false. We also can't really associate a portrait with a given number. We could technically, but what does that mean to us as developers? If we say portrait is equal to the value 5 and landscape is equal to the value 10, and that's how we know which one we're referencing, that doesn't really make a lot of sense to us logically. This is a perfect case for enumeration. We can define essentially a predefined set of values like portrait or landscape, And each one of those values can tie together to a number, and that number is actually what VBA is going to use internally to process our request. And that way, we don't actually have to memorize the concept of relating numbers to portrait or landscape. We just have to identify whether we want portrait or landscape, and that given name will correspond to a given value that VBA can then use. It's a little bit of a confusing concept, so let's explore this actually within the VBA documentation. I'm going to open up my browser here, and I'm actually going to search for right now the worksheet VBA object. We're going to dive into the documentation before we write any of our code. Here is the documentation page for the worksheet object. And on every worksheet object, there exists a property called page setup. So I'm just going to scroll down here until we get to our properties, not our method. So properties, let's look for page setup right here. There it is. So page setup is a property that actually gives back to us a page setup object, yet another object in our Excel object model. Here in our page, we have, of course, the description, returns a page setup object that contains all of the page setup settings for the specified object. Pretty generic documentation, but we can click here. So we're continuing to traverse the Excel object model. Here we're going to get to the page setup object, and this represents the entirety of our actual page setup. So that includes everything from like the left margin, the right margin, the margins, things like the footers, all of that stuff that relates to how that page looks, especially when it's printed. There is a property on the page setup object called orientation. So here it is, orientation. This is how we're going to be altering whether the spreadsheet is going to be in landscape or portrait format, which again is going to affect how it looks when it's printed. And here's a good example. If we take a look at the code here, we see that we're targeting a worksheet, we're targeting the page setup object, we're targeting the orientation property, and here we're setting it to something interesting, Excel landscape. Notice that this isn't a string. We know that automatically because it's not wrapped in double quotes. So what is Excel landscape? Well, it's the idea of an enumeration. This is some kind of name that corresponds to a given value. How can we find out what that is? Well, right here we see that we can use the orientation property to return or set an Excel page orientation value. So what is this thing right here? Let's go one step further, continuing to traverse the object model, and here's where we're actually going to get to the Excel page orientation enumeration again. So what are we doing here? We have a convenient table that corresponds or relates the idea of a name with a value, right? So behind the scenes, whenever we're going to give a name, VBA is going to be able to translate it to a value. And why is this advantageous? Well, because as developers, we don't have to memorize these values. These values are kind of random, right? How do we associate the idea of a landscape with number 2 and a portrait with number 1? We really don't. The VBA community or the developers have just arbitrarily decided that those two values are going to represent those two settings, and we're going to use those two numbers, or rather the code is going to use those two numbers to set some kind of internals of Excel to give that given appearance. But for us as developers, we don't have to actually associate or memorize these values. All we have to do is use the given names, and VBA will translate these names into their numeric values. That's the whole idea of an enumeration. Remember, a name tied to a given numeric value. This is like the Big Burger combo, and we're tying it to number 2 on the menu. So now we can go ahead and see this concept in action in our actual Visual Basic editor. So let's go ahead and define a procedure. I'm going to call it change orientation. Now, in order to get VBA to help us with our actual enumerations and our predefined constants, it's a good idea to define variables that represent Excel objects. That way, IntelliSense can figure out what object we're referring to and show us all of its properties and methods. So what we actually want to target here is the page setup object. So the way I can do that is declare a variable. Let's call it PS for page setup, and we're going to do as page setup. Remember, whenever we're declaring a variable to be an object, whatever's after the as keyword can be any object in the Excel object model. Worksheet, worksheets, workbook, etc. Page setup, as we just saw, is a valid object that's nested within a worksheet. So let's go ahead and set that page setup object. So remember, whenever we're assigning a value to a variable that holds an object, we need to start with the set keyword, set PS, and now I need to target a valid page setup object. Well, we know that exists on an actual worksheet, so we can target a worksheet like worksheets. Let's target sheet 1. As a reminder, whenever we use this syntax, we're automatically going to assume the active workbook, or rather VBA will assume that. That means the workbook that is currently activated or selected. In this case, we only have one open, so by default, it will be the active workbook. All right, and here on a worksheet object, which I've taken out of the collection, we have a property called page setup, which returns to us a valid page setup object. So we've defined that variable, and now whenever we go to PS and place a dot, the IntelliSense is going to show us all of the properties and methods that are available on a page setup object. We, of course, are looking at orientation. So when I do orientation and I do equal, here's where VBA is going to be really helpful. It's going to show us all of the predefined constants or enumerations that are available. Notice here that the values of these constants are irrelevant. We don't know which one of these is represented by number 1 and which one of these is number 2. We have access to that in the VBA documentation, but it doesn't really matter because as developers, we don't have to think about it. We don't have to memorize it. It's abstracted away. That complexity of associating numbers with what is going to happen on the spreadsheet in terms of orientation, the Excel VBA code is going to take care of all of that for us. All we have to do here is just provide the right constant, the right name, and the code under the hood will take care of the rest of the process for us. And the great part about the names is that they're a lot more logical. The number 2, again, doesn't mean anything. However, something like Excel landscape is kind of logical to us as users. We can associate it with, that means we want the orientation to be of landscape. So let's say I select landscape right here. So I'm just going to select tab. That should lock it into place. Let's just double check that our orientation right now is set to portrait perfectly. Perfect. So what's going to happen here is we're going to change the orientation from the default right now, which is portrait, to landscape. And we're going to do that using this predefined constant or this enumeration. All right, let's go ahead and execute this, F5. Now we're not going to see anything visibly, but if I go here in orientation, we can see that it's been swapped to landscape. Let's go ahead and switch that back to portrait. I'm just going to remove this value right here. Once again, type an equal sign, and there again, we're going to see 2 values. Now, kind of as an obvious reminder, depending on the property that we're going to be accessing, we're going to see a different set of available predefined constants or enumerations. It all depends on the property that we're adjusting. There are enumerations related to navigating across the worksheet. There are enumerations related to charts and tables. They're all just predefined options, predefined values that map or relate to a given name. That allows us to not have to think about the number and only have to process the name that we need. So what do we want to do now? Well, we want to change the orientation to portrait. We can safely guess as a developer that Excel portrait is the one that corresponds with the portrait orientation. We can select that. Again, under the hood, behind the scenes, Microsoft's code will translate this to a number. It's going to know what to do with that number in order to turn the orientation of the worksheet into a portrait. So when I execute this, F5, check here, the orientation has been changed back to portrait. That's all there is to cover in this lesson. We talked about the idea of predefined constants, also called enumerations. We're going to be seeing this concept a lot throughout the course. Again, these constants exist whenever we have a value that's a little bit difficult to represent with something simple like a string or a number. We could, of course, tie together the idea of an orientation with a number, but what would that mean, right? What the heck does a number 2 mean when it comes to portrait? We're really just trying to represent a limited set of options, kind of a list of possible values, but a number isn't really perfect. A string is kind of functional, but again, typing in a string like portrait doesn't always work. What if the user enters a typo, things like that. So the reason that these constants exist, these enumerations, is so that we have these predefined things that we as developers can use that are less likely to run into errors. And behind the scenes, VBA will just translate these names to given values, and it knows what to do with them to accomplish the effect that we want. That's all there is to cover in this lesson. I'll see you in the next one.